Hello, science family. Today we are looking at worksheet number 5, which is a quiz review option. We've been looking at 1 and 2 step type of mole problems. And if you notice in the directions, something that's good and important to look at is, first of all, decide if this is a 1 or 2 step problem. And then from there, make sure you're using your map and following your directions, and you should be good to go. So first off, we're starting with 34.4 liters and going to grams. So if you're starting off with liters, volume island, and going to grams, which is mass island, that means you're going to be doing a 2-step type problem, right? So maybe make a little note to yourself that that's going to be 2 steps. So we're going to start with definitely what we're given, 34.4 liters of carbon dioxide. And since it's a 2-step, I'm going to give myself 2 spots to write. Now I'm starting at volume island and I'm heading to mole island, so I'm going to be using my mole map. And it says to put 1 mole on top, and I'm going to keep that the same compound, CO2. And on the bottom, it says to put 22.4 liters. That's for my conversion factor. Next up, I'm going to go over to mass island, which means I'm going to use my bottom conversion factor. It says to put molar mass on the bottom. When I added up carbon dioxide, I ended up getting 44.01 grams of carbon dioxide off the periodic table over 1 mole of carbon dioxide. Now, once I do that, again, double check. Liters cancel, moles cancel. You're left with grams, so that looks good. Put that all in your calculator, and you end up with about 67.6 grams of CO2. Make sure you throw that in your calculator and see if you're getting the same answer. If not, you might be doing your calculator work wrong. Checking out number 2, we're going from grams to moles, which means I'm just headed from mass to moles. So this is going to be a 1-step problem because I only need to go to 1 island. So let me start with what I'm given, 96.52 grams of oxygen. And since it's 1 step, I'm only going to need 1 conversion factor. In fact, since I'm going from grams over to moles, I'm going to use this top conversion factor. And it says to put 1 mole on top. I'm going to keep that O2 for oxygen. And then on the bottom, notice it does say molar mass. Molar mass is 2 oxygens off the periodic table in grams. 16 plus 16 is 32 grams. Now that I have that, I should be pretty set up. Double check, do the units cancel? Yes. I'm left in moles, which is what I wanted. And when I multiply by 1 on top and divide by 32 on the bottom for my starting number, I end up with 3.02 moles of oxygen. Double check your calculator work, make sure you get the same answer. Checking out number 3, I've got 12 grams of sulfur dioxide, and I'm going to liters. So if I'm starting in grams, I'm going to head over to mole island, and then I need to go to liters, so I'm going to head up to volume island. That means I'm going to use these 2 conversion factors, which means that this is indeed a 2-step problem. So I'm going to take my 12 grams of SO2, always start and write down what you have, and it's going to be 2 steps, so I'm going to leave 2 spots for my 2-step problem. Perfect. Step 1, go from mass island to mole island. It says 1 mole over molar mass, so that's what I'm going to do. 1 mole of SO2 over the molar mass of SO2. When I added up 1 sulfur and 2 oxygens, I ended up with about 64.07 grams of SO2 for every 1 mole. That is what I get my molar mass for. Next, now that I'm in mole island, I'm going to head up to volume island, and the conversion factor tells me to put 22.4 liters of SO2 up on top for every 1 mole of SO2 if it's at STP. STP, remember, stands for standard temperature and pressure. We'll get more into that way deeper when we get into gas laws. But let's see, grams of SO2 cancel, moles of SO2 cancel. So remember, multiply by top, divide by the bottom. So it's going to be 12 times 1 divided by 64.07 times 22.4 divided by 1. And what I ended up getting is about 4.19 liters of SO2. Do that in your calculator, double check, make sure you got the right answer to make sure you know you're plugging in your calculator correctly. We're hammering out number 4. I've got 78 molecules of C6H12. Molecules is in the particle world, and I'm headed to liters. Liters is in the volume world. So this is a 1-2-step problem. So since it's two-step, you just got to be prepared that it's going to be a little longer of a problem. So I've got 78 molecules of C6H12, and I know that I'm going to have 2 steps. All right, step 1, particles to moles, says to put 1 mole on top of C6H12, and Avogadro's number on the bottom, 6.02 times 10 to the 23rd. As we always say, make sure you know how to put that number into your calculator properly. Otherwise, it can create some issues with your answer and get the wrong thing. Now that I'm in mole island, I'm going to step over to volume island, which is 22.4 liters up top of C6H12. And on the bottom, it says 1 mole. So I'm just following my map. Notice the map naturally does the canceling for you of units. You got rid of molecules, you got rid of moles, and now you're left with liters, which is great. Multiply the first number by the top and divide by the bottom. Multiply top, divide by the bottom. And what you end up getting is about 2.90 times 10 to the negative 21st power. And that is molecules of C6H12. Sorry, I had to squeeze it in there. But if it's 2.90 times 10 to the negative 21st, is that a very big or a very small number? If you said very small, you're correct. Remember, the negative exponent means your decimal goes to the left 21 places. So that would be a 0.0000000, 20 zeros, and then 290. So an extremely small number. All right. And forgive me too, I made a mistake. That's not molecules for the final unit. That should be in liters. So very, very small volume. And notice how I checked my answer and thought, you can't have that few of molecules, like less than, that didn't make sense. So when I look back, double checked myself and caught my units. So good job if you caught that too. Let's take our final example problem here. We'll be halfway through then, number 5. I'm going from 0.568 grams of carbon monoxide to moles. So I'm going to start at mass island and head over to mole island. My friends, that's just going to be a 1-step problem. So since that's a 1-step problem, let's get going. We're going to always write down what we have, 0.568 grams of carbon monoxide. 1 step means I'm just going to have 1 conversion factor, and in fact, I know it's the top one. So I'm going to put 1 mole of carbon monoxide on top, just like the conversion factor says. And on the bottom, it says molar mass. So if I take my molar mass, remember that's just the mass out the periodic table. So 1 carbon plus 1 oxygen, I end up with about 28.01 grams of 1 mole of carbon monoxide. So now that I have that, let me double check my units. Do grams cancel? Yes. I'm left with moles, which is what I wanted. So everyone's happy. Let's just rock it out. 0.568 times 1 on top divided by 28.01 on the bottom. I end up with a fairly small number, 0.02 moles of carbon monoxide. Very well. There you go. So part of it is making sure, hey, how many steps am I doing? Second then is follow the map. And third, just make sure you're using the right conversion factors. So if you're going from mass to moles, don't be using the bottom one. Make sure you're using the top one. And you should be fine. But this hopefully is helpful for you all, science family. Keep up the good work. And of course, ask questions in class and stop in for intervention time, whatever you need. But this should be a great, springboard for you to get kicked off. But good luck on that quiz coming up.